Okay, we are going to go ahead and take a look at one of your pre-lab questions, and I'm going to help you through it. And the key thing to remember is that simulation 2, 3, and 4 are going to be set up the exact same way that this one is. Give me just a second. I'm going to try to focus this a little bit better. There we go. Hopefully that's a little bit better. Here is that key equation, understanding that whatever amount of heat our metal absorbs right here is going to be given away, which is why we see the negative Q there. And that's going to be given away to the water. So the water is actually going to be absorbing that heat from the metal. And we talked about this in class on Friday. Of course, we understand that Q is represented by mass times specific heat times delta T. And that's why we see that equation on both sides. I've run through the simulation and collected some data over here to the right. Keep in mind that final equilibrium temperature could vary just depending upon when you stopped the simulation. So I just kind of waited until it hit the max temp that I saw, and those are the final temperatures I wrote down. But yours might be a little bit different, and that is completely okay. The same thing's going to happen in the lab. So on the first one, let's take a look here at the mass of the metal. I see that it was 20 grams, so I'm going to go ahead and write that in, times the specific heat of the metal for gold is 0.128. Write that in. And then delta T here, the initial temperature of the metal was 105, and then the final temperature of the metal was 21.71. So for me, 21.71 minus 105 is going to give me negative 83.29. And again, I keep that negative over here, and you'll see why in a moment. I'm setting that equal to the water, and the mass of the water was 30 grams, times the specific heat of water we know is 4.184 or 4.18. And then the temperature of the water, the initial temperature was 20, the final temperature 24.13. When I subtract that, I get a positive 4.13 because, again, remember that final minus initial. When I combine what's over here on the left, I get 517.902. And remember, I'm not going to deal with sig figs until the very end of the problem. And on the right, I get a negative 20 times a negative 0.128 times a positive 83.29, and I'm going to get something wrong. I looked at the wrong temperature. Over here, that shouldn't be 4.13, excuse me. That should be 1.71. Teachers make mistakes too. Over here, excuse me, that should be 213.22 equals, it's negative there. Let's try this other calculation again. There we go, 214.434. And you look at this and you're like, now, Ms. Vaughn, those aren't the exact same numbers. Guys, that goes back to looking at those temperatures and understanding that there's some experimental error here, just no different than with the simulation. You may have used your specific heat of water as 4.184. That could have potentially changed something. And then, of course, up here on this final temperature, you may have written down 21.72 or 21.7, which again would have changed your answer down here as well. But what we see ultimately is that the amount of heat given off by the metal is the amount of heat absorbed by the water. And that's what I'm ultimately wanting you to see. So for over here, you're going to do the exact same thing. You're going to have Q of the metal equals Q of the water. And I just want you comparing those values on each one and understanding that however much heat is taken in by the metal, that's the total that could possibly be absorbed by the water. Hope that makes sense. I am going to go ahead and work on another pre-lab question in the next tutorial.